1.10 Types of Discontinuities. So, this lesson we're starting to get into what continuity is. So, if you look at this graph, in simple terms, continuity is if you can draw the curve without ever lifting your pencil, then the function is continuous. You see this graph here, continuous. On the right here, you see the graph. This bottom part here I can draw, but then to get the other part I have to lift my pencil up and then start drawing. So this is not continuous specifically at x is equal to 0 because that is a point where I must lift up my pen before continuing. There's three types of discontinuities we're going to go over. First one is called a hole. And parentheses, write this part, removable. The reason this is called removable is because if I just filled in this hole here, it would be continuous. This is just the one place, a hole is just one place in the graph where it is discontinuous. Question 2, we'll call discontinuity because of vertical asymptote. Vertical asymptote, asymptote. And this is non-removable. This is non-removable because there isn't just one place we can fill in that would make the graph continuous, so it's non-removable. So the third one here is jump discontinuity. And this is non-removable as well. So this is a jump discontinuity right here. You see this graph here, then you jump up or jump down in other graphs, but in this case you're jumping up, and it's non-removable because there's no one point you can fill in that would make this whole graph continuous. So here are some practice questions right here. For each function, identify the type of each discontinuity and where it is located. So whenever you have these here, the first thing you want to do is factor this. If you factor x squared minus 8x plus 12, that's x minus 2 times x minus 6. And then if you factor the denominator, x squared plus 3x minus 10, you get x minus 2 times an x plus 5. So you can see here that there's x minus 2 on the top and bottom. So you see when x is equal to 2, that's a 2 minus 2, 0, 2 minus 2, 0 on the bottom. This is what we call a hole. Anything that factors out on the top and bottom is a hole. And you see what's left. You have an x minus 6 over x plus 5 left. Whatever you have for an x value that makes 0 on the bottom after it's simplified, that's where it's a vertical asymptote. So when x is equal to negative 5, you see the bottom is 0, but the top isn't. That's what we call a vertical asymptote. I'm going to call it VA for short. And again, this here is removable. And this here is a non-removable discontinuity. Question 2. First thing you should do is factor this out. You have x plus 1, you can't change anything with that. And then you have x squared minus 1 times x squared plus 1. And then to factor that again, you have a x plus 1 over x plus 1, x minus 1, x squared plus 1. So you see the x plus 1s cancel out on the top and bottom. Therefore, x equals negative 1 is a hole. And then you have a vertical asymptote. Well, vertical asymptote at x is equal to 1 because When x is equal to 1, the bottom is 0, and the top is just a 1 remaining once you cancel the x plus 1s out. And x squared plus 1 can never be 0 because x squared is always positive. Like x squared cannot be a negative 1. So there's just one value there for vertical asymptote. And again, remember, x equals negative 1, the whole is removable, and x equals 1 is vertical asymptote non-removable. So this next one here is a trig one. It can be optional if you feel weak with your trig because you don't see questions like this come up as much on the AP exam unless it's a calculator. But if you felt good with your trig and want to do it, the first thing to do is rewrite tan of 2x, which is sine of 2x over cosine of 2x. And you can see there's nothing you can factor out on the top and bottom. So you just have to figure out when is cosine of 2x equal to 0. Cosine of 2x is equal to 0 when, let's see here, at these points here, cosine 2x is equal to 0 when x equals pi over 4, 3 pi over 4, 5 pi over 4, and 9 pi over 4. However, 9 pi over 4, that's outside the bounds here, so you don't use this. All these values here are vertical asymptotes. So again, because there's nothing that cancels out on the top and bottom, and we're just finding when cosine of 2x is equal to 0. This last question right here, f of x equals x squared minus 1. This isn't a fraction. Well, if you think about it as a fraction, right, it's x squared minus 1 over 1. Normally for wholes, we find something on the top and bottom to cancel out, but there's nothing here. Vertical asymptote, well, when is the bottom 0? Never, because 1's always going to be on the bottom. This is just a continuous function. Any polynomial such as x squared minus 1 is always continuous. Therefore, there are no discontinuities. If there are, all right, that's it for 1.10. If there were any questions, please ask your teacher, especially if you need a refresher on how to factor, and if you want to, how to find some of these solve for these trig functions. Thank you.